In the summer of 1968, a construction crew was scraping at a sandstone outcrop on a cattle ranch near Wilsall, Montana. They were after loose rock and gravel, ordinary work on ordinary land. Then, the front loader bit into something that did not belong. Tucked into the slope, stained a deep rust red, was a cache of stone spear points and carved antler rods. More than 100 objects, laid down with care by human hands. And under that ochre-covered toolkit lay the bones of a child, a boy, barely more than a year old when he died. He had been buried 12,600 years ago in the deep cold of the last ice age. For decades, nobody knew who he was. Nobody could ask the bones a single question, but the answer was already written inside him, in a code we did not yet know how to read. And when we finally learned to read it, that small skeleton from a Montana hillside would rewrite the family tree of an entire hemisphere. This is Bedrock, where we dig into the first chapter of the Americas, the people who walked this land before the maps, before the names, before the borders. No reenactors, no actors, no invented experts. Just the dirt, the bones, and the science that learns to speak for them. In this story, I am going to show you 3 things. First, how a single child ended up buried under a fortune in stone tools, alone, in the Ice Age North. Second, how a frozen genome turned that child into the most important burial ever found on this continent. And third, the question his blood forces every living person in the Americas to ask about where they truly come from. Stay with me, because the twist in the middle of this is the kind of thing that ends old arguments for good. To understand why one small grave matters this much, you have to understand the Clovis people. Around 13,000 years ago, a culture spread across what is now the United States, and we know them by a single signature object, a spear point. Long, fluted, chipped on both faces, with a channel carved up the center so it could be lashed into a wooden shaft. Archaeologists call them Clovis points, after the town in New Mexico where they were first found in the 1930s. These were the tools of mammoth hunters, people who walked into a continent full of giants, animals that had never seen a human throw a spear, and made a living off of them. For a long time, the Clovis were thought to be the first Americans, the founding population of 2 continents. Here is the strange part. We had thousands of their spear points scattered from coast to coast. We had their butchering sites, their stone, their campfires. What we did not have was a single one of their bodies. Not one confirmed Clovis burial in all of North America. This is not just old bones lying in a museum drawer. The grave near Wilsall is the only known burial of a Clovis individual anywhere on Earth. Picture that. An entire founding culture, known almost entirely by the weapons they left behind, and exactly one human being we can put a face and a story to. That one human being is the boy from Montana. Go back to that hillside in 1968. The land belonged to the Anzac family, so the boy carries their name in the science. Anzac. The site was not excavated by a careful team with brushes and screens. It was hit by heavy equipment, a collapse of sand and stone, and the bones tumbled out almost by accident. What the workers found, once people understood what they were looking at, was extraordinary. The child had been coated in powdered red ochre, an iron-rich pigment used in burials across the ancient world, a color tied to blood and life. Around and above him sat the tool cache, more than 100 items, spear points napped from fine stone, long rods carved from antler or bone, beveled at the ends. Some of the objects looked deliberately broken, the way grave goods often are, killed to travel with the dead. These were not random scraps. This was a deposit of enormous value to people who made everything by hand, and they gave it all to an infant who could never have hunted a single mammoth. Think about the labor frozen in that grave. Every spear point took hours of careful chipping at a slab of stone. Every antler rod was ground and beveled by a person crouched at a fire in a frozen valley. All of it surrendered to the earth, above a baby. Someone loved this child, or feared what his death meant, enough to bury a small fortune with him. and then the bones sat. For decades, they passed through private hands and university shelves. The skull and the tools were studied, measured, photographed, but the boy himself stayed mute. The technology to truly read a body that old did not exist yet. The boy waited, silent, holding his secret, while the science slowly caught up to him. So hold that image. A child, 12,600 years dead, lying in storage while the world he never knew kept spinning. Because everything changes when a new kind of tool arrives. Not a stone point this time. A way of reading the past that the Clovis people could never have imagined. By the early 2000s, scientists had learned to pull genetic material out of ancient bone. Old material is brutal to work with. The genetic code shatters into tiny fragments. It soaks up contamination from everyone who has ever handled the sample, from bacteria, from the soil itself. For years, ancient remains gave up only scraps, but the methods kept improving, sample after sample, lab after lab. And researchers realized that the boy from Montana was the prize of a lifetime. Here was the only Clovis individual on Earth, old enough to sit near the very root of the American family tree, preserved well enough that his genetic code might still be readable. A team led by Morten Rasmussen, working with the lab of S.K. Willerslev, one of the pioneers of ancient genetics, made the decision. They would attempt to sequence the entire genome of a child who died at the end of the Ice Age. What does it actually mean to read a genome that old? It means taking a fragment of bone, often just a sliver, and chemically coaxing out the surviving strands of genetic material. Those strands are broken into millions of short pieces, like a book put through a shredder 12,000 years ago. Specialized machines read each fragment, and computers stitch the overlapping pieces back into order, comparing them again and again until a full sequence emerges. For the boy from Montana, the team recovered enough to read his genome cover to cover at high quality, an astonishing result for remains that old. But the stakes were bigger than one child. For years, a fierce debate had run through American archaeology. One side held the standard view that the first Americans came from Asia, crossing the land that once connected Siberia to Alaska, the region called Beringia, and moving south. The other side pushed the Solutrean hypothesis, the idea that Ice Age people from Europe crossed the Atlantic along the edge of the sea ice and seeded the Clovis culture from the east. Stone tools alone could not settle it. The boy's genome could. Whatever was written in his code would point either toward Asia or toward Europe. There was no hiding from a full genome, but the first result was only the beginning. The data came back, and the direction was unmistakable. The boy's deepest ancestry pointed across the Pacific, toward Asia, toward the people who had crossed Beringia. The Solutrean idea, the notion of an Atlantic crossing from Europe, found no support in his genetic code at all. That alone was a major finding, an answer to a decades-long argument delivered by a child who died before the argument existed. The Clovis were not transplanted Europeans. They descended from the same Asian founding population that everyone had long suspected, the people who walked east out of Siberia when the world was colder and the seas were lower. So, one mystery closed, and here is where most stories would stop, with a tidy answer about origins. But the researchers kept reading, and what they found next was not about where the boy came from. It was about who he left behind, because a genome does not only point backward into the past, it points forward, toward everyone who carries a piece of it today. And the boy from Montana, it turned out, had carried a great deal forward. When the team compared the boy's genome to living people across the Americas, the pattern was staggering. He was not a distant cousin to today's native populations. He was a direct ancestor. The study found that the boy belonged to a population directly ancestral to a large majority of present-day indigenous peoples of the Americas. He was more closely related to Native American groups than to any other people on Earth, and the connection was strongest of all among the indigenous nations of Central and South America. Popular coverage often puts a number on it. Around 80% of living Native Americans, tracing ancestry back to the boy's lineage. The exact percentage is the kind of figure that gets simplified in headlines, so hold it loosely. But the core finding from the original study in the journal Nature in 2014 is rock solid. This single infant, buried under spear points on a Montana ranch, sat near the root of the family tree for 2 entire continents of people. The genome also supported a single ancestral migration from Asia into the Americas, one founding stream that branched and spread until it filled the hemisphere. Not waves of unrelated newcomers, one deep source. The boy was a window into that founding population, frozen at the moment it was still close to its beginning. There are very few human remains anywhere that can claim what his can. A line of descent running straight from one ice age grave to tens of millions of living people. Most ancient genomes give us a person, isolated, a single life flickering once and going dark. The boy from Montana gave us a beginning. He sits at the place where the branches of the American family tree have not yet split apart, where the people who would become the great nations of 2 continents are still one stream, still close to the source. So let me reframe what is actually sitting in that grave. We tend to look at ancient bones and see a specimen, a thing, a data point in a study. But the boy from Montana is not a specimen. He is a grandfather. Not in metaphor, in genetics. If you are indigenous to the Americas, especially to the lands south of the modern United States, there is a strong chance that the blood in your veins runs back through the centuries to that small body on the Montana hillside. The people who buried him, who painted him in red ochre and laid more than 100 tools above him, were not burying a stranger at the edge of a dying world. They were burying the start of a family that would outlast empires they never saw coming. Every mammoth hunter, every farmer, every city builder, every nation that would rise across 2 continents over the next 12,000 years, an enormous share of them carried a thread that passes through this child. He is one of the oldest known direct ancestors of the indigenous Americas that we have ever held in our hands. A founder, and he was barely a year old, which brings us to the detail that lingers. After the genome was read, after the papers were published, and the debates were settled, the boy did not stay in a lab. In 2014, the year his genome shook the field, local Native American tribes carried him back to the Montana ground he came from and reburied him. The descendants, reclaiming the ancestor, scientists had learned everything his bones could tell. The migration, the family tree, the answer to the Solutrean question, and then the living family laid the founder back to rest near where the construction crew first disturbed him almost 50 years before. He has no name that we know. No words of his survive. No face, no voice. We do not even know exactly how he died, only that he was loved enough to be buried like royalty in a world without kings. He is remembered now, not by a name, but by a number on a hillside, and by the millions of people who, knowingly or not, descend from the line he stood near the start of. So here is the thesis, and the question I want to leave you with. The boy from Montana proves that the story of the Americas is not a story of many strangers arriving from many directions. It is, at its deepest root, one family from one founding population, spreading across 2 continents and becoming everyone. That is the bedrock under all of it. But his story also opens a harder question, and I genuinely want your answer in the comments. His bones gave us the single migration, the family tree, the end of the Solutrean argument. None of that would exist if he had simply been left in the ground. And yet his descendants chose to rebury him, to put the knowledge back to rest. So where do you stand? When we find the remains of an ancestor this old and this important, should science be allowed to study them fully before anything else? Or do the living descendants always get the final word on whether their grandfather is read or returned to the earth? Tell me below, because there is no clean answer and I want to hear yours. If you want more first chapters of the Americas, the people under the maps, subscribe and stay with Bedrock. The ground here remembers everything, and we are only just learning how to listen.